This is Pre-Calc section 6.6 part 2, solving linear systems using inverse matrices. In the previous video we learned how to make the inverse matrices both for a 2x2 and a 3x3 matrix. Now we're going to use that inverse to solve a system of equations. So number one, you write the matrix A for the coefficients. What does that mean? Matrix A, just the coefficients of x and y. So this is 1, 6, -3, 6. We do the determinant. 6 times 1 is 6 minus -18 gives me a determinant of 24. As long as the determinant does not equal 0, that tells me there is an inverse matrix. So the inverse matrix is going to be 1 over 24 times this thing rearranged. All of this is what we did in the previous video. So there's our inverse. The only difference is I am not distributing this because it will make the next step a whole lot easier for it not to be distributed. So there's our inverse matrix right there. We're going to multiply that by the constant column, 27, 39. So we first find the inverse, but we do not distribute, and then we multiply, and then we will do the distributing. So this will be 1 over 24 on the outside. We'll get to that in a minute. Now you got to think about what kind of matrix is this? Well, this is a 2x2. This is a 2x1. Because those match in the middle, you know you can multiply them, and your answer will be a 2x1, which is like this. 2 rows with 1 column. All I have to do now is do this multiplying. If I do this row times this column, I'm looking at 6 times 27 plus -6 times 39, which comes out to be -72. You can use your calculator to verify that. This row times this column, 3 times 27 plus 1 times 39, which is going to give me 120. Now distribute the 124. So -72 over 24 gives me -3. 120 over 24 gives me 5. That gives me the ordered pair -3, 5 is the solution to my system. So let's take a look at another one here without all of those steps written in front of us. If we are solving this by the inverse matrix, we need to find the inverse of this matrix right here. So 2, 3, 3, 4, using the steps we learned in the last video. So get the determinant. 2 times 4 is 8, minus 3 times 3 is 9. The determinant is -1. That tells me there is an inverse. And I will write 1 over -1 right now so I don't forget that determinant on the outside there. Then I'm going to rearrange this matrix. The 4 and the 2 swap places, and the 3 becomes negative. This 3 becomes negative. I need to multiply it by the constants, -10, -12. So multiply, 4 times -10 is -40, plus -3 times -12 is 36, which gives me -4 in that position. And for this, -3 times -10 is +30, plus 2 times -12 is -24, gives me 6, and I just have to distribute -1 through there, which turns this into +4, -6. I'm not taking time in the video to explain why the inverse solving works. I will show you that in class. Now, to do the 3x3, there's more work because finding the inverse of a 3x3 is a little bit more difficult. So number one, write your matrix using those coefficients, the coefficients in front of x, y, and z, being sure that you copy correctly, because if you make a little mistake on the copying, everything will be wrong. So there is my original matrix. Then I'm going to use the diagonal method. So I'll write 2, 1, -3 on the outside, 1, -2, 1 here. Come down this diagonal. 2 times -2 times -2 is +8, plus 1 times 1 times -3 is -3, plus 3 times 1 times 1 is 3, minus this. -3 times -2, 3 is going to be 18, plus 1 times 1 times 2 is 2, -2 times 1 times 1 is -2. Do your arithmetic there. We will get an 8 on the outside because those cancel. Inside here, the 2's cancel. So this is 8 minus 18 gives me negative 10. That tells me the inverse does exist. So now I need to do all of my work with the minors. Put my negatives in those 4 positions. Cover this row, this column, and do the determinant arithmetic. That is, negative 2 times negative 2 is 4, minus, that's the down, minus the up, minus 1. So 4 minus 1 is 3. Move your covers, move this over, look at that 2 by 2 matrix. 1 times negative 2 is negative 2, minus, come back up, negative 3, minus or minus is plus, is going to give me a 1 in this position, which is already established to be a negative position. Therefore, it stays negative 1. Move your covers. Get this determinant. 1 times 1 is 1, minus negative 3 times negative 2 is positive 6. 1 minus 6 is negative 5. Keep moving the covers. This time now we're going to move this down to the middle row, go back to that column covered up, and look at this one. This is 1 times negative 2 is negative 2, minus 3 is negative 5, going into a negative position, turns this into positive 5. Move your column cover over to the middle and multiply here. 2 times negative 2 is negative 4, minus negative 3 times 9 is negative 9. Minus and minus is plus. Negative 4 plus 9 is 5. Move your cover over to the third column. Get the determinant of that matrix. 2 times 1 is 2, minus negative 3 times 1 is negative 3. Minus and minus is plus. That's a 5 going next to that negative that's already there, makes that a negative 5. Move your bottom cover, or move your cover to the bottom. Move this over to the front and look at that 2 by 2. 1 times 1 is 1, minus negative 2 times 3 is negative 6. Minus and minus is plus, gives us 7. Move your cover over to the middle column. 2 times 1 is 2, minus 3 times 1 is 3. 2 minus 3 is negative 1. Going into that negative position means this is going to turn into a positive 1. And last cover movement over here. Multiply 2 times negative 2 is negative 4. Minus 1 times 1 is 1. Gives me negative 5. That's the hard part. Now we have to transpose this. And this notation for that would be just put a little t right here. The transpose of that matrix tells me to take the first row and write it as the first column. Being sure that you don't drop off any negatives. Middle row as the middle column. 5, 5, negative 5. Bottom row as the last column. And that is your matrix transposed. But remember, you also have to multiply this by the 1 over the determinant of negative 1/10. That is your inverse matrix. You're not finished with getting the inverse. Now we need to multiply that inverse times this matrix of the constants. And just to double check as far as multiplication goes, this is a 3 by 3. This is a 3 by 1. The 3's match in the middle tells me it is able to be multiplied. And my answer matrix will be a 3 by 1. So 3 rows, 1 column. And don't forget, this will be multiplied by negative 1/10. You could distribute negative 1/10 through here. I just think it's easier to deal with integers and then take care of that fraction at the very end. So now we're multiplying this row times this column. 3 times 1 is 3. 5 times negative 3 is negative 15. 7 times negative 4 is negative 28. Where am I getting those numbers? The first in the row times the first in the column, plus the second in the row times the second in the column, plus the third in the row times the third in the column, and that gives me negative 40 right there. This row times this column, negative 1 times 1 is negative 1, plus 5 times negative 3 is negative 15, plus 1 times negative 4 is negative 4, which gives me negative 20. Bottom row times the column, negative 5 times 1 is negative 5. Negative 5 times negative 3 is positive 15. Negative 5 times negative 4 is positive 20, which gives me 30. And then I need to multiply each of those by negative 1/10, which gives me 4, 2, negative 3 in matrix form, which means the ordered triple 4, 2, negative 3. And you can check that by plugging those back in to those 3 equations.